There now. All right, hello. Hello. Let us learn all about applications of maximizing and minimizing quadratic functions. Remember that we have cupped up and cupped down quadratic functions. The vertex is the turnaround point. Typically, we call this HK, but H is sometimes used for other things, like it is here in the first problem. So, we're going to get rid of H and K. And we're going to do this. We're going to go back to basics, remembering that the vertex is a point like any other point. It has an X coordinate and a Y coordinate. It's just that we often give special letter names to the X coordinate and the Y coordinate, but it's not at all necessary. This is the X coordinate when you have a maximum value. Now here, I've taken this function, we'll read the problem in a minute, but I've taken this problem and I've graphed it so that I could show you that the x-axis is not the x-axis this time. It's the t-axis for time. And the y-axis is not the y-axis, it's the h-axis for height. Height above the ground. So as time goes by, the rocket is higher and higher and higher until it reaches the vertex, and then it won't go any higher. Doesn't have the energy to go higher. So it will start coming back down to Earth. The vertex then, for its X coordinate, is going to have time, and for its Y coordinate is going to have the maximum height. Now the X coordinate or the T coordinate, time, that goes with the maximum height is going to be negative b over 2a. And then when we take whatever that number is and put it in for the t's in the function, the answer we get will be the maximum height. So the number of seconds to the maximum height is negative b over 2a, which ends up being 5 seconds. Negative b over 2a. And the maximum height is going to be what you get when I take 5 and put it in wherever, substitute it for every t. I just think of it as putting it in for the t. That's what substitution is. And we find out the answer is 406 feet. So after 5 seconds, our little toy rocket will be 406 feet above the ground. Notice that this is all you're being asked to do. Let's read the problem. A toy rocket is shot vertically into the air from a launching pad 6 feet above the ground. with an initial velocity of 160 feet per second. That's what the 160 means. And the 6 comes from the initial height, the height in the beginning. The height h in feet of the rocket above the ground at t seconds after launch is given by this function. How long will it take the rocket to reach its maximum height? How long means time. Time acts like x. So that's what you use to find negative b over 2a. Then what is the maximum height? That's the maximum value, k. And you always find k by taking your x coordinate of the vertex, your negative b over 2a, and plugging them in for the variable in the function. We're going to do that a lot in this video. Another important thing, notice that this is a cupped down parabola. So the maximum value you find, or the maximum or minimum value you find for this cupped down parabola is automatically a maximum height. So you don't have to worry about it. Okay, let's move on. We've got Aki's bicycle designs, and I picture them in my mind as being a bicycle shop on Dixon Street in Fayetteville. Aki's bicycle designs has determined that when X hundred bicycles are built, the average cost per bicycle is given by this function, C of X, where C of X is in hundreds of dollars. How many bicycles should the shop build to minimize the average cost per bicycle? Well, this is a cupped up parabola, so you're going to be finding the minimum cost. Cost is acting like the y coordinate. Here's your cost. And bikes, B-I-K, phooey. All right, so we'll do this. Now make an arrow. This is going to be bikes, because I don't want to take the room to spell out bicycles. Bikes and cost. Now here they're asking how many bicycles should the shop build to minimize the average cost per bicycle. They're not asking you to find the minimum cost. They're asking you to find how many bicycles. That means all you have to do is find negative b over 2a. B is negative 0.2, so negative 0.2 over 2 times 0.5. Well, 2 times 0.5 is 1, and negative is positive. So the answer we're going to get is 0.2. We need to build 0.2 of a bicycle. Well, no, not true. Because remember, each X stands for 100 bicycles. So if I get the answer 0.2, it's really 0.2 times 100 bicycles. So 20 is the answer. Notice when you've got a cupped up parabola, you have a positive leading coefficient, you have a minimum value. And you have the x-coordinate that makes the minimum value a minimum value. Be sure to watch this over again. I remember doing this when I was a student in college algebra, and in the beginning I found it terribly confusing. But you get used to it, and it stops being confusing. So don't be scared off. Here we have some very important information for you. How do you find profit? How do you get profit? You get it by subtracting. That's what the word difference means. The profit of a company in dollars is the difference between the company's revenue and cost. Difference means subtraction, and the order of these words is usually how you set up your subtraction. Revenue minus cost. That's what profit is. The cost, C of X, and the revenue, R of X, are functions for a particular company. The X represents the number of items produced and sold to distributors. So X is what you're building and selling. It's going to cost you money to create those items. And when you sell them, you're going to be taking money in. So you take money in and then you pay your bills, and whatever's left over is your profit. Determine the maximum profit. That's money. Money is almost always either the maximum or the minimum value. You can't just find it. This is a trick question because B is the x-coordinate items. Determine the number of items that must be produced and sold. I graphed this for you. Notice you have a cup down parabola. Here's the vertex. Here's the maximum value. And here's the number of items that must be produced and sold in order to create the maximum value. So let's take a look at this. The first thing I have to do is find profit. To do this, I will take revenue minus cost. In the beginning, I start out with both of them in parentheses. Now there's an understood 1 in front of both sets of parentheses. There's an understood 1 here and an understood 1 here. The thing is, the 1 has a negative sign in front of it, so it's really a negative 1. So 1 times 790x minus x squared is just 790x minus x squared. But here you have to distribute the negative 1 times 2000 and times positive 50x so that you get negative 2000 minus 50x, and that would be minus 2000. So our profit is 790x minus 50x, which gives us 740x. Move the negative x squared to the front because you need to be in descending order. And the constant is negative 2,000. So here is your profit function. Now, the number of items you need to sell, build and sell, is going to be negative B over 2A. Because the profit is dollars, that's going to be on the y-axis. That means items are going to be on the x-axis. Negative B over 2A is negative 740 over 2 times negative 1, which is negative 740 over negative 2, which is 370. You're going to need to produce and sell 370 items, whatever those items are. That's the x-coordinate of my vertex. Now to find the maximum value, I take 370 and I substitute it for every x, which gives me $134,900. That is my maximum profit. My maximum profit, 134,900. Don't put a, well, never mind. You can put a comma in the answer box if my math lab says it's okay. But not here, or you'll have 2 commas, and that would be a pain. It would also be misunderstood. So you want to try to get clear on what are the x-coordinates and what are the y-coordinates of the vertices. That's the plural of vertex. A careful reading and a few tricks, like knowing dollars are usually on the y-axis, and other things like items produced or time is going to be on the x-axis. Here, the items are conveniently referred to as x, so you don't even have to guess. Okay, one more. There's a farmer who needs to enclose 2 adjacent rectangular corrals for sheep and cattle. The river is going to form one side, so the farmer doesn't need to use fencing here because he's limited. They are limited to 390 yards, not 391, 390 yards. So we're going to have a width, a width, a width, and a length. But we don't have to worry about this other length because there's going to be water there. Find the largest total area that can be enclosed. That means maximize the area. Maximize the area. What is the largest total area that can be enclosed? In other words, what is the maximum value? What is the maximum area? And we're going to have to work with 2 formulas. Our perimeter here, our fencing, has an unusual formula. There are 3 W's and 1 L. So 390 equals 3W plus L. 390 yards of fencing. The other formula, and I want to circle these in a different color. This is the fence, which is the same thing as perimeter. And this is the area of the two corrals together. This is what I need to maximize. There's no way I can maximize this. This is just, well, both of these variables are to the 1 power. So it's a straight line of sorts. Straight lines just keep going. You can't minimize them or maximize them. This, on the other hand, you have a chance to maximize. So let's look at it. If I solve for L so that I get 390 minus 3W equals L, and then move that over here to the area formula and put it in for that L, then I'll have 390 minus 3W in parentheses times W. And when I distribute the W, I will have a quadratic. And when I write this in descending order, I see that the leading coefficient is negative, which means I'll have a cup down parabola, which means I'll have a maximum value. So I am definitely going in the right direction here. So now, how do I maximize? I have to find negative b over 2a first. Negative b over 2a. That's negative 390 over negative 6, which is 65. And since our variable in the area is W, this is the length of the width, if you will, the measurement of the width that will cause the area to be maximized. So I'll have 65, 65, and 65. Now the area, well, the length will be forced to be 195, and the area, there's no choice. Once you know what W has to be, everything falls out from there. So there are two ways you can maximize this. You can put 65 in for each W, and then calculate the answer. Or you can do it the really easy way, since we know the area of a rectangle is length times width. I've already got the width. What if we just quickly find the length, which is 195 yards, and then multiply length times width? Or here, I multiplied width times length. Same thing. And the answer is 12,675 square yards. Lots of room for cattle and sheep. Actually, I don't know what makes lots of room for cattle and sheep. These can be difficult. I remember, like I said before, how confusing it can be to work with two formulas and use one for substitution and the other one as the receptacle of the substitution. But with practice, you start getting the idea. You start feeling more and more comfortable, which is one of the reasons for homework. Homework builds up body memory, and it builds up body memory. You just get better at it. Your reasoning gets better too. So remember to look back over the video or look through the video and do your homework and read the notes, and they will help you. Talk to you later. Bye-bye.